All right, let's take a look at writing radicals in simplest form. So let's really make sure that we do a good job of understanding this part because this is going to be a crucial skill for the rest of the unit. Yeah. All right. So let's take square root of 45. So square root of 45. So what we want to do with these is we want to rewrite 45 as some perfect square times some other number. So before we get going, let's actually just write down our perfect squares. So if you remember, perfect square would be, so 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And then 25, 36, 49, 64, 81, 100. And then sometimes we'll need 121 and 144. Okay. So these are going to be the numbers I'm interested in because I know the square root of all these numbers. That's going to be the whole point. So let's go back to my square root of 45. So I started thinking, okay, what number can I divide 45 by, right? From my list. So obviously not 49, not 36, not 25, not 16, but 9, right? I can divide 45 by 9. So that means that we can rewrite 45 as times 9 times 5. All right, so why did I do that? Well, the reason I did that is because now I've broke it up, right? Because we can actually, if we wanted to, rewrite this now as the square root of 9 times the square root of 5. I don't typically do that. Like, I kind of skip this step usually. I just kind of go straight from this one. But this is really what's happening, right? Because now that I've split this up, I actually know the square root of 9. It's 3. So on the next level down, I can say, well, okay, this is really 3 times root 5. So there you go. That is my radical written in simplest form. All right, so let's type that in. So we've got 3. And if you want to be fancy, you can type in square root like that. If you missed that, SQRT, and then 5. Or you could have pressed the button as well. You probably figured that one out by now. All right, so let's look at the next one. So square root of 363. All right, so we'll go square root of 363. So now maybe you're not sure, right? Because yeah, sometimes it's a little bit confusing, like what it might be, right? So let's just try dividing by a few of these. So if you grab your calculator. So maybe you're thinking, well, maybe 144. So then we'll say, okay, 363 divided by 144. That's not going to be it, but let's say you tried. And you're going to see that it's 2.15, yada, yada, yada. So that's not it, right? 144 doesn't go into 363. But what about 121? So we got 363 divided by 121. And you probably could have seen that one, right? Because 3 times 121 would be, just multiplying all these by 2, you get 363, right? So, okay, so 121 goes in. So if you remember, the square root of 121 is 11. So, okay, so let's use that. So we've got 363. And I'm going to rewrite this now as, get my pen. I'm going to rewrite this now as the square root of 121 times 3. All right, so now, like I said, I could break this down in the next step, but really from here, the way I think about it is I'm like, okay, 121, I know the square root of that. So I think about it as just like taking it out of the square root now. So the square root of 121 is 11, so it gets to come out of the square root, but now it's an 11. So I got 11 and then root 3. Okay, so then if we type that in, we get 11 square root 3. Okay, let's take a look at 640. Just going to erase these for a little bit more room. Okay, so we got the square root of 640. All right, so grab your calculator again. Then we can just start trying to divide 640 by some things. So 640 divided by. Now, you can do it. There's actually two that go in this time. So if I go 640 divided by 16, right, that's perfect square. That's 40. And if I go 640 divided by 64, I get 10. Now, what I'm going to recommend you do is take the larger one. So usually, like when you're looking for things that go in, start with the bigger numbers and then work your way down. Just because it requires less steps. You can kind of do it in one step. If we chose 16, it would actually require that we like simplify it twice. Yeah, so maybe I might actually just show you both, just so you understand how that it would work either way. So if we got 640, I'm going to rewrite this with the bigger one first. So this would be 64 and 10. So the square root of 64 times 10. Okay, now 64 gets to come out as 8. So there we go. Our answer is 8 root 10. Now if we had have done 16 and 40, so if we would have said, okay, square root of 640 is the square root of 16 times 40, then we could have said, okay, well the 16 gets to come out. But so the square root of 16 is 4. So now I have 4 root 40. Okay, well those don't look the same, but what about this? I can still break down 40. So I'm going to write this now as 4 times the square root of, and I'm going to split this up as 4 times 10, because 4 is a perfect square. So now I get to take this 4 out, and when I take it out, I'm actually going to take it out as the square root of that, right? So it's coming out as a 2. So on the outside here now, I've got 4 times the 2 I just took out, because they're written beside each other, so yeah, you multiply. And then I've still got root 10. And then just actually multiply 4 times 2, I get 8 root 10. So you can see I get there either way, but it was definitely easier when I just picked the bigger perfect square to go into it first. All right, square root of 80. This one shouldn't be too bad. So now square root of 80. So now I'm going to rewrite this as some perfect square times something else. Okay, so in this case, let's try, well, let's do 16 and 5. Okay, now you could have done 4, just like in the last example, right? But I just want to take the bigger one. So 16 I get to take out as a 4. So I get 4 root 5. All right, one more. So for our last one here, we've got the square root of 891. So again, we would try to find one of our perfect squares that went into it. And in this case, if you divide it, it's 81 times 11. Okay, so now 81, I know the square root of that, right? The square root of 81 is 9. So I get to take this 81 out of the square root. And when it comes out, it's a 9. So we get 9 and then root 11.